Hello and welcome to this Python tutorial. So it's not actually a real Python tutorial because basically we will just make a template. It will be a regression template. And so why are we making this template? It's because we're going to now fit other nonlinear regression models on this same dataset containing the position levels and the salaries. And therefore the code to build these models and visualize the results will pretty much look like this code that we wrote for polynomial regression. So we're going to make a regression template that not only will help us build very efficiently some regression models for our truth or bluff problem with the position salaries, but also you will be able to take this template, take it with you, take it at home, at work, and you'll be able to use it to make some predictions of real values on your dataset. However, if you have more than 2 dimensions in your dataset, then you won't be able to visualize the results on a graph, but you will definitely be able to fit, your nonlinear regression model to your dataset and then make those predictions of some new observation thanks to the predict method. Okay, so what we're going to do now is we're going to take everything here up to the end. There we go, copy, and we're going to paste it in our regression template. There. Okay, and now we're going to change a few things. So in the preprocessing phase, we will of course not change anything because, this imports the dataset. We have the correct indexes here, so that's fine. We don't need to change anything here. We will need to split the dataset into a training set and a test set for the same reason as for polynomial regression, because we have a very small dataset with only 10 observations. However, if you're using this regression template for your dataset to solve your business problem, then you will probably have more than 10 observations, and then you will need to remove the quotes here to not leave it as a comment, and therefore create a training set, to train your machine learning model, and then test the performance on a separate test set. But for our problem, we will leave that as comment because we won't need this. Okay, and feature scaling, well, we will leave that as comment, because most of the libraries we're going to use to build our nonlinear regression model actually don't require us to apply feature scaling manually. So actually that's okay for the preprocessing phase, and we can move on to the next steps. For polynomial regression, we fitted this linear regression model to our dataset as well to, use it as a reference base to compare the linear regression results to our nonlinear polynomial regression results. Well, since we have the linear regression results in mind now, and we know that it's a poor model with a poor performance for this specific problem, we will actually remove it to only focus on our future nonlinear regression models. Okay, so speaking of nonlinear regression model, that's actually our next step, because here we build this nonlinear regression model and we fit it to our data set. So here, since it's a template, we will actually remove polynomial here. And we can replace it by fitting the regression model to the dataset. Okay, and we will remove everything here because this code section creates the polynomial regression model, and in the future sections we will build nonlinear regression models. So let's remove that and let's move on to the next step. So the next step is the visualization of the regression results. So I'd like to have this step as the last step of our regression template for 2 reasons. The first reason is that, it's the most fun and exciting step. And the second reason is that our data set is non-linearly distributed. So we now know that we have to predict the salary of this 6.5 level with a nonlinear regression model. So that's why I'd rather, keep this visualization step as the most exciting step for the end after the predictions themselves. Okay, so the template is almost ready now. We will get rid of this because we have the linear regression results in mind. All right. And same for this prediction here. Let's keep in mind that the predicted salary of the 6.5 level was $330,000. So let's just keep that in mind. But what we're mostly interested in are the future predictions of this 6.5 level salary with our future nonlinear regression model other than polynomial regression. Okay, so let's remove this. Almost ready. We just need to change one tiny little thing. It's the fact that the future nonlinear regression models will not be based on linear regression itself. What I mean is that, we built our polynomial regression model just by adding some polynomial features into the multiple linear regression equation. So, we built this linear regression object and we fit it to our transformed matrix of features X that we transformed thanks to this polyreg object that is adding the polynomial features to our original matrix of features X. But for the future nonlinear regression models that we're going to build, we will not do that. We will not create a linear regression object, and we will not transform the original matrix of features into a new one. So we will actually get rid of this linreg object here and here as well, and also get rid of this polyreg object and also its fit transform method that we have right here. So I'm going to get rid of that here. Same for these parentheses, that were just the parentheses of the fit transform method. Here we go, and same here. Okay. So we're getting very close to the final template, and now the only last thing that we need to do is to take the old good method that we used, remember when we had this ypred variable. So here ypred is not going to be a vector of predictions, but it's going to be the predicted salary of this 6.5 level. And here, since we got rid of the linear regression model, we're going to create our regression model here by creating a regressor object from the appropriate class, and therefore, exactly like before, we will use here our regressor object with the predict method to predict the salary of this 6.5 position level. And that's it. That's actually the only thing that we need to write to predict this 6.5 level salary with any new nonlinear regression model. And therefore, same here. We will use our regressor object, which will be our nonlinear regression model, and then we add a dot here because we will use the predict method of this regressor object to predict, actually this time, the salaries of all the position levels contained in our matrix of features X, and no need to do any transformation in the future. And that's actually ready. Well, we can replace that by visualizing the regression results. Let's call it this way. And here, same, let's just replace polynomial regression by regression model. Okay, so the template is ready now, Let's give a quick recap. So in this first part here, we do the pre-processing phase. We don't need to split the data sets into the training set and test set because we only have 10 observations. We don't need to apply feature scaling because most of the regression libraries don't require us to do so. Here we will create our future nonlinear regression models. So, we will import a class from a certain library. Then we will create a regressor object that we will call regressor. And then we will fit this regressor object to our data set using the fit method. And then in the next step, we will predict this salary of this 6.5 position level. And then in the last step, the most exciting step, we will visualize the regression results. That is, we will visualize the curve that our nonlinear regression model builds and fits to our data set. Okay, now for those of you who are also interested in this code that plots the regression results in high resolution and giving a smoother curve, well, we can add this optional code section below by, copying this one and paste it here and just specify here for higher resolution and smoother curve. All right, so remember what we need to do is to create this new X grid here that will contain all the levels from 1 to 10 plus the imaginary levels 1.1, 1.2, 1.3 up to 9.7, 9.8, 9.9. That is all the levels from 1 to 10 incremented by 0.1. So remember, to create this new array of levels, we need to use the arrange function of numpy, and then in this function we need to specify the lower bound, which is min x, that is level 1, then max x, which is level 10, and then the step, which is 0.1. All right, so these three parameters here, but remember this gives us a vector and we would like a matrix, because in this plt.plot here, x must be a matrix. So that's why afterwards we used the reshape function to restructure this vector x grid into a matrix of len x lines and one column. So here, remember, we take our x grid vector again, dot, and then that's where we use the reshape function. And in this reshape function, we need to specify one argument here. So these two parentheses is the argument itself. And in this parenthesis, we need to specify the number of lines, which is len x grid, and the number of columns, which is 1. Alright, so that transforms your original matrix of features X into this new matrix X grid containing the 90 levels from 1 to 10 incremented by 0.1. And here, of course, we need to replace X by X grid, and then here as well, so that the models now predicts the salaries of those 90 imaginary levels from 1 to 10 incremented by 0.1. And therefore, the blue curve will have a lot more points to plot on the graph because it's now predicting 90 salaries of 90 levels. So that's why by doing this, we'll get a much smoother curve. All right, so we're actually done with the model here. We can remove this to even more generalize. And here we'll just specify that that's where we create our regressor. Great, so now our template is ready. And so we are ready to use it for the next nonlinear regression models that we're going to build in the next sections. So I look forward to creating these new machine learning models with you. And until then, enjoy machine learning.